Welcome back to math class. This is Mrs. Witt, and this is lesson 15.1 about solutions for Math 7 Accelerated, whether an equation has one, none, or many solutions. We're going to start by doing an activity, and if you're in the classroom, we're all going to be moving around together, but if you're at home, I want you to consider each of the following situations carefully. And when we think about these statements that you're about to see, I want you to think about, yes, it's always true. No, it's not true. Or sometimes this thing can be true, sometimes not. It has to be under certain conditions. And the activity is that if we say, yes, it's true, we're going to stand up. If we say, no, it's not true, we're going to sit down. And if we say sometimes it's true under certain conditions, take a knee. Okay, so for the sake of this video, I'm just going to give you a few seconds on each one to consider it, and then we will move on from there. This star has exactly 5 points. This star has exactly 5 points. Stars have exactly 5 points. 5 pennies is equal to 2 quarters. $1 is equal to 4 quarters. $1 has the same value as 2 quarters and 5 dimes. 2 equals 2. 21 equals 4. 2 plus 2 equals 4. 2 plus 1 equals 4. 2 plus 1 equals 2 plus 1. 2 plus 1 equals 4 plus 12. 2 plus x equals 4. All right, so I hope that you took the few minutes to really consider those problems and think about when you found times that something was true no matter what, not true no matter what, or could be true under certain circumstances. Okay, for us to get started, I want to go ahead and review the things that the language we're going to be using so that we can remember where we are and what we're all talking about. For the sake of this lesson, a variable we know is going to refer to an unknown. Often you'll see it represented as a letter like X or Y, but it can be anything. A constant we know is a number that is constantly the same, like 4 is always 4. It doesn't wake up and suddenly turn into 17. An equation is 2 values that are set equal to each other. And a solution is a value that makes that statement or that equation true. So I want us to kind of consider, let's kind of go back to one of those warm-up examples where we had a star that looked like this and a star that looked like this, right? And then just a statement about stars. And it's asking whether it has 5 points. So here we would have said that, does this star have exactly 5 points? Yes, that was true. That's always true. But then when we look at this star, we say, does this star have exactly 5 points? No, it is not true. This star has 6 points. And then finally, when we think about stars in general, just random stars, all different kinds of stars, right? It says, do stars have 5 points? Well, sometimes that's true, right? Because the first star had 5 points, but the second star did not. So depending on what star you're looking at is whether or not the statement's true. It's only true under the condition that it's a star that has 5 points. So think about that. Now, when considering equations, we're going to switch gears a little bit. I want you to start thinking about when would something have one solution? When might an equation have no solution? And when might an equation have more than one solution? So we're going to pause on that for just a second. If you're an Edpuzzle, there'll be some questions that pop up for you. And I want you just to consider carefully what your thoughts are for each of those situations before we move on. Okay, to help answer those questions, let's work through some examples. So let's ask ourselves, how many solutions does this equation have? Well, let's first think, well, how do we find a solution? What is a solution? Well, a solution is where we try to find a value of x that makes it true. So we need to find the value of x. So first we're going to solve. And when we solve, we're going to use inverse operations, right? To try and get one copy of x on one side of the equal sign. And then presumably that means that anything left over is on the other side. So to solve these, the first thing we have to do is make sure that all of our x's are together on one side. And then we narrow that down to one copy of the x. And once we have one copy of the x on one side alone, then we know that that's as far as we're going to go to find that value. So looking here, I have 4 x's on the left side and 16, the constant number 16 on the right side. Okay, so I am going to use my inverse operations. 4 times x, well, the inverse of that is 4 divided by x. 4 divided by 4 goes to 1, so that goes to where I don't need to write it anymore because I've just got one copy of x left on the left side. 4 divided by 16 is just 4. So have I met my goal? Did I solve it? I used my inverse separations, and now I have one single copy of x on one side of the equal sign. And what I'm left with is x equals 4. So how many solutions do I have to this problem? I just have that one solution, right? I have one solution. It tells me what my one solution is. My solution is 4. 4 is what makes this statement true, right? So if I picked 5, 5 wouldn't work. If I picked 2, 2 wouldn't work. But under the condition that x equals 4, that the value of x is 4, then this statement is true. So let's kind of write this down, make sure we get this in our notes. If a variable can be isolated on one side of the equal sign, and then it's true only when it equals that number. So if x is 7, it's not true. But if x is 4, it's true. That's its condition. It is conditional. On the condition that x equals 4, this statement will be true. So it is true one time. It has one solution, x equals 4. Okay, well, that was easy. That's kind of what we expected, right? Well, let's take a minute and look at another situation. How many solutions does this equation have? 4x equals 4x. So take a minute and try to work that out. Remember our goal. Let's write that down. What is our goal? Is to solve. We want one copy of x on one side of the equal sign. So let's take a minute and try to do that. Well, if I look at this, I have 4 x's on the left side, and I have 4 x's on the right side, but I want all my x's on one side. So I like to kind of look at the left side. So I'm gonna take all the x's that are on the right side, I have 4 of them, and I'm going to do the inverse of that. So I've got positive 4x's. I'm going to use negative 4x's, or I'm going to subtract 4x's from that side. What I do to one side, I have to do to the other side to keep it balanced. Okay, so let's see, on the left side I've got a positive 4x and a negative 4x. Well, that leaves me with 0 x's, right? So I've just got 0 there. On the right side I've got a positive 4x and a negative 4x. Well, again, that just leaves me with 0. Okay, so did I do my job? Did I get one copy of x on one side? Is it possible to get just one copy of x on one side and not have any other x's left in the equation? When you try to solve for x and the x's either add or subtract to 0, or it turns into 0 x's. So basically they disappear, they go away. When my x's have gone, and I'm left with a true statement, such as 0 equals 0. Well, that's absolutely true. 0 does equal 0. Well, how often is that true? How many times is 0 going to be equal to 0? It's going to be true anytime, all the time, a million times, many times. So this is going to be many times true, or have many solutions. Now, what does that mean? Well, that means that since if we look at it logically, whatever's on the left side is equal to whatever's on the right side. So if I multiply both sides by x, I'm going to scale that at the same rate, right? So if I took 1 times 4 on the left side and 1 times 4 on the right side, I'd still have 4 on both sides. I'd still be even. I'd still, have a true statement. But what if I took 10? If I tried 10 times 4, well, on the left side I'd have 40, and on the right side I'd have 40. It would still be true. There are many solutions, or many values of x. One might say infinitely many values of x that I could plug in, and it would still be true. So how are we going to sum that up? Let's think about it. If the variable adds to 0 and the resulting statement is true, then it will always be true. It's an identity. No matter how many times I try it, it's still going to be true. So it has many solutions, or you might say infinitely many. Sometimes you'll see infinitely many. Sometimes you'll see things where it's written as infinitely many or infinitely many. For the sake of our homework this week, you can just write the word many. Okay, so now let's consider a different option. How many solutions does this equation have? X plus 1 equals x plus 2. So let's think about that for a moment. So remember our goal. Our goal is to solve this, getting one copy of x on one side of the equal sign. Okay, well, let's look at this. There's an x on the left side and there's an x on the right side. Well, that's not good. We need to get our x's together. So I'm going to take this x over here on the right, and I'm going to use my inverse operations. Right now it's a positive x, so I'm going to combine that with a negative x to get rid of it on the left side. Or I'm sorry, on the right side. So what I do to the right side, I have to do the left side. Well, x minus x, that just becomes 0 x's. I still have a 1. X minus x, well, that became 0 x's again, and now I've got left with a 2. So how is this different from the last problem we just had? Does 1 equal 2? No, that is not true. There is no truth to that. It's not true now. It won't be true tomorrow. It's never going to be true, right? There is no truth to that. Well, if there's no truth to that, we would say there is no solution. And why would we say that? Well, because no matter what we plug into x, it's never going to make 1 equal 2. So if the value of x is 1, let's just try that. If the value of x is 1, 1 plus 1 on this side equals 1 plus 2 on that side. Well, 2 equals 3. Nope. Let's try 10. Well, that's 11 equals 12. Nope. No matter what I plug in for x, adding 1 on one side and 2 on the other side will never let it be equal, right? And we found that out by solving and getting it down to its most simple form, where we spotted really quickly that 1 is not equal to 2. But it's just a matter of recognizing that there's no way that logically that can be true. So how can we sum that up? How many solutions does this have? Well, if the variable adds to 0, like we did before, so it goes away. If the variable adds to 0 and the resulting statement is false, then it has no truth. It's a contradiction. It has no solution. So no truth means no solution. Okay, so now you're going to try. I gave you a little bit more complicated problems to work through. But what is this asking? This is not asking you to necessarily solve, but it's asking you how many solutions do these equations have? And your answer choices here, you can say they have 1 solution, no solution or none, or many. So I'm going to give you a few minutes and you're going to work through those on your own. All right, so I've worked through the problems for you. You can check your work. You've already worked them out on Edpuzzle, but I wanted you to notice that in the first 2 problems, no x's were left over. They subtracted to having 0 x's. One gave you a true statement, one gave you a false statement. And then finally, I was able in the last one to get x alone by itself, and it was equal to -7. So I know that is true on the condition that x equals -7. If x is something else, then it wouldn't be true. All right, so I want you to consider something here for a minute. Just looking at these lines, how many times do each of these lines touch? And how might we relate that to whether or not our statements are true in these equations? Just think abstractly for a little bit. In the first one, these do not touch. How many times do they touch? They don't touch. They do not touch, not even once. And what about the next one? How many times do they touch? Well, they touch many times. They overlap each other, right? One lays on the other. And then finally, this last one. It only touches right there. It touches 1 time. So later on, as we begin graphing some of our lines, we're going to be exploring how the graph of the line relates to how many solutions it has. So for instance, maybe if we're graphing 2 lines that never touch, there's never going to be an answer that satisfies both of them. If we're graphing 2 lines that lay on top of each other, or they touch many times, then that one may have many solutions. And consider, what does that mean for the last situation when we have 2 lines that touch exactly 1 time? What might we infer about how many solutions that would have? Okay, so let's kind of recap all this and put it together nice, neat, and pretty. We know that equations can have one, many, or no real solutions. And to solve, what we want to do is we want to try to get one copy of the variable. We talked a lot about, it being x, but it could be anything. But what we want is we want one copy of it on one side of the equal sign. We can get that by using inverse operations. And if we do that, when we see that it has one solution, that means that it looked something like x equals some number, right? So that means we know that x is true conditionally when x is whatever that one specific number is. When it has no solutions, we're going to have, let's say 4 and 2. Well, we know that's not true. So we'll say that x has no truth. Then we know we're going to have no solution. But if it said 4 equals 4, well, that's always true. X is always true. It's true many times. So that's when we're going to have many solutions. And that looks like an identity, right? 4 does equal 4. And the other one here, this looks like it is a contradiction. Have you heard your parents ever say, "Don't contradict me"? That means don't say something against what I'm saying. Don't say something, in this case, it means not true. All right, well, with that, I believe you have enough to get started on your choice board. So, happy learning.